Hey, welcome to AIT on a Friday afternoon. We wanted to talk about thermocouples, temperature control, and maintaining equipment, do's and don'ts, and those kind of things. Our Frank Sutton is going to take us through this, starting with kind of the main focus here of the brass rings and so forth.
Okay. On our brass rings we have thermocouple wiring. It's coming from the thermocouple. We also have brushes. We have two on top. We have two down at the bottom, which are hard to see, but they're down there. They're transmitting the signal from the thermocouple through the rings to the brushes and then up and over to the board. We will get to the board on our next episode of J-Tube at AIT. But for now, what we have is this thermocouple wire, and when our temperature is fluctuating above and below our set point, and also even alarming out sometimes, first thing I do is I check to see if my wires are tight, which this one is not.
What the heck?
So we don't twist our wires, we just kind of put them together, knot them together, then fold them in half.
Now, are those is that two wires?
It is, the two red wires put together. These are your positive wire coming from the thermocouple. Here is the white, which is the negative, one white wire. They are tightened down through these little set screws here. And then on the back side, if you can't use if you don't have good fingers because they're so big and fat, use a pair of tweezers. That helps a lot. Sometimes I have to use those to get the wiring into
that hole there.
Yeah, it's a very small hole. So once it gets back in there, we'll do that. I'll take the set screw. We'll just snug it down, not over tightening, but not loose. No. Hey, you know what I didn't do? I didn't put it in there. Good thing I checked it.
Should they check these? I don't know. They don't need to be weekly, but I guess when you see a temperature issue, come check these connections.
I would check these connections every time you come and clean your rings, because there's no telling what may or may not have been pulled on when you're cleaning. You can do a lot of different things to pull those wires out, jar them loose, and so forth. So every time that I have to come in and clean the rings, which could be once a week, could be every day, I always check wiring anytime I come in here. As far as skis go, I just take my finger and brush those off. You can also see that there's a set screw right in there. That set screw keeps this from swinging left and right. So when you're initially your first install of these new brushes, make sure that's tight so that it won't flip over on you. So you sit there nice and tight.
So generally just check all these connections, because just like everything else on the heat press, as it heats up and cools down, you're subject for things to get loose.
Correct. And when people are cleaning incorrectly, you can knock wires loose.
How should these? What should they use to clean these brass rings?
What I use is a 120 grit. Some people call it emery cloth, but I just take this and I just lightly sand as the drum is turning. Just rubbing this back and forth, and once it gets all the way around, you can see nothing. There's no dirt, not any kind of residue on the rings. You're good to go. At cool down, on a lot of the machines, a lot of the newer models, they have this little
damper wiper.
Right? It comes out when you push cool down. This will pop right out, and it sits on that drum for at least 2 revolutions, maybe 1-2 revolutions, and then it's done. It's cleaned. It's daily crap that's gotten on the rings off
I see.
We usually, when we do a good cleaning with a piece of sandpaper, is because we have hard, pressed on, cooked on material that dampener is not going to clean off.
I got you.
So you cannot rely on that dampener to clean your rings. That's just for a daily dusting and anything that's just on top.
Mm-hmm. What about the thermocouple itself? I mean, that's it over there in the shell of the, isn't that it? Where is it?
Yes, there's your thermocouple right here in the drum. It's in there snugly. Doesn't have to be tight. You don't want it so tight that you can't, doesn't move, but you don't want it to be loose where it's flopping.
Yeah.
You want it to where it'll sit still. If it's not movable, then it's too tight. You've probably crushed your thermocouple. I wouldn't mess with it until you need a new one. But when you put your next one in, don't over tighten it. Just snug it down to where it's not going to move, because you can break your thermocouple by over tightening.
Okay. Okay, we're back at AIT and looking at a temperature control board, single thermocouple. Our Frank Sutton is going to take us through some do's and don'ts.
All right, we just replaced this board. We upgraded this machine from a dual probe to a single probe, and what I've done is I've turned this board around from original. All this used to be back there.
Oh, so you've turned it 180 degrees.
Turned it 180 degrees, and the reason I did that is because I can now reach this little pot right here. I can see it, and I can see what's going on when I do my calibration. Now, this is about calibration. If this were on the other side, you wouldn't be able to see it. So I just loosened up some wires and cut a few straps, zip ties to loosen everything, and flip the board around so I can reach it. And now we just kind of put these screws back in, hold it in place, and we're ready to do our calibration. Now, to do calibration, obviously we start with temp strips. So we'll come around to the front and we'll look at what we've got here. Our temperature is reading 114. Our set point is 107. Now, once this reaches 207, obviously my temp strip, I should run this through to see what it is, what my temperature is. So, at a set point of 207, unless this says 114, but this says 199.
Let me focus on that.
So our temp strip is saying 199. Obviously, we're off a few degrees, but what we want to do, obviously, is if your machine is colder, the numbers are lower than your set point, and your temp strip is telling you so, then we want to move these numbers down by turning that little blue pot.
Okay, let me come back around. I think I showed everyone that before.
What I do is I'll set my screwdriver right on top there. You can see where I've got it set in there.
Yeah.
Now I just hold it and I come around to the front, and then if I want this machine to go, if I want it to warm up because it's not hot enough, then I will turn the temperature, the actual temperature, down. So you see it going down, and that brings the temperature up. Now, I know.
So what they should do is they should set this to exactly what this temp strip is.
Yes, that's what the goal is to get this number and your temp strip to read exactly the same.
Okay. And how do you get there? Do you just make the adjustment carte blanche here on the lower set point?
No. What we normally do is to make our adjustments. Obviously, I have my screwdriver on my adjusting pot. I run my temperature strip. My temp strip tells me what my actual temperature is. This is going to be my secondary temperature, meaning I don't use that as my rule of thumb. I use my temp strip as my rule of thumb. It's what I'm adjusting this to. So once this reaches its set point, it thinks that it's a temperature, but my temp strip says different. So if my temp strip says that I'm about 6 degrees off, but my actual temp says that I'm at 207, then obviously I'm going to turn that number down so that it will heat up some more and actually gradually increase by my temp strip.
I got you.
And it is also the reverse if it's too hot. So if we have a temp strip here that reads 210 Celsius, then obviously I would turn my actual temp above, higher than the set point, so that it cools down. Because what happens is when you go above your set point, your solid state relays turn off, and if you go below your set point, then your solid state relays turn on, which means heat or no heat.